Hello everyone. Today we're gonna see how to test paired two samples. It's like called paired two sample t-test. So let's look at the datasets, then we will understand what we are going to do. First, I just imported some necessary libraries, pandas and scipy stats from Python. So we have a dataset for the scores before training and after training. So if you see, we have an employee and we have his or her score before training, and let's assume that we trained them and we got new scores we got test and we got new scores, and we are going to test whether these two score is significantly different from each other. Like, to be more precise, the scores after training is scores after training higher than the scores before training at 5% significance level. So this is our question. So scores after training is higher than scores before training at 5% significance level. So the first thing we should always do is creating our hypothesis. Hypothesis null is scores after is not higher than scores before. So it means it's not higher. The train doesn't have effect. The next one says scores after training higher than scores before training. So it means this is what we are going to prove. So it's our hypothesis alternative. So what we should do is I just took these two columns as a different variable before and after, and we should first find the difference between pairs. So I should subtract every scores after from scores before. So this is what I did. So if you look here, I subtracted all columns. It says minus, plus. Some employees have better scores, some have bad scores compared to before training, and we need to find t-statistics. T-statistics can be found by first we need to find the mean, and we need to divide it by the standard deviation power 2 divided by the number of samples, length of the difference. So this is what I did as a formula. So if I run, I have t-statistics, which is very high, 7.49. So our p-value can be found by using Python scipy stats library. Here we should do stats.t.cdf. So first we need to assign t-statistics, then n-1. n-1 means degree of freedom. Degree of freedom is how many samples we have minus 1. So if I print this, it will give me print. Okay, I have 0.999 almost equal to 1, and as I said, as we agreed, our significance level is 5%. So here our p-value is actually it's upper tail test, not lower or two-sided. So this tests where it's lower. So if we minus this, it gives us this value, which is very close to the 0. Let me do this itself also, so we can so both of this plus this equal to 1 actually. So this is lower p, this is higher p, as our alpha is 0.05, our lower p is almost 0, we should reject null hypothesis. If we compare differently, we can also say, okay, if alpha is 0.05, the higher sides should be 0.95, meaning 95% of our p-value, higher p-value should exceed from this amount, so that we can reject our hypothesis null and accept hypothesis alternative. So we are rejecting it because alpha is higher than p-value. So the second way how to do this is just one line of code: before, after, alternative, greater. So here we are doing stats t-test. Here we are not using independent because it's not independent. We are using relative. It means paired to test t-tests. So before, after, I'm just giving what I've did here, what to compare. So here it says compare before, compare after, and find alternative greater. Actually, I should switch it after, before, I think. Yes. So compare this to before and find whether it's greater or not. So it gives us p-value and t-statistics. So t-statistics is 7.949, so this value what you calculated, and p-value is 2.2, almost 0, it's this value. So we can also do this way. So you can do whichever applies for you, and I hope you understand what we are going to do and what we did. And if you have any questions, you can ask me in the comment section below. See you on the next videos.